All right, heading into what I hope is the last video for this cool multi-sim lab. The level coming out of the filters and the clipper is a little low. We've noted that already. If we bring up interactive mode, and which we'll do right here, I'm going to go back into interactive mode, and I press play. I should see in green there, that's probe 1. So that's coming into the circuit. And you can see we've lost a lot of level here. The light blue, that's what's leaving the clipper. And the one that's not really very rounded, that's the filtered response. Now, this is assuming right now that you have set, like I have set, the drive potentiometer. Like I can increase this whole guy, right? But I really can't ever get makeup gain. I'm going to put this back to 50%. So we need to put some makeup gain on this circuit. And the way we're going to do it, let's just take this out of actually, hold on. Is there anything else I wanted to say about this? No, there isn't. So the way we're going to do this is we're going to put another op-amp in here. Op-amps are great for gain. But unlike the two previous op-amps, we are actually going to put a voltage divider in the feedback circuit, which is going to reduce the voltage coming back into the negative terminal. And by having less voltage than on the output, it actually amplifies. That's how you control the amount of amplification, is by changing this level on the on the feedback terminal. So we're going to have to put in this op-amp here. A little bit more about that. This is the equation for how you figure out which resistors you want. This is for a non-inverting configuration of an op-amp. This is not for one that reverses polarity. This has one where you have the audio signal coming in on the plus here. But it's 1 plus RF, and RF is the resistor in the feedback circuit over Rn, which is the resistor used to ground in the voltage divider. So this is our equation, and these are the settings that I've picked. And I very specifically have picked matching resistors here. And I kind of know, I already know intuitively what that's going to do, but the math shows you here. 1 plus RF over Rn, that's 1 plus 10,000 over 10,000. 10 plus 10,000 over 10,000 is 1. So we get a gain of 2. What this means is this op-amp is just going to double the output voltage. It's a very simple equation here based on the fact that you have equal resistors. If we do this into the dB math, I know you love dB, but what is a factor of 2? A factor of 2, let's take 2 volts over 1 volt and get the log of that, times it by 20 to do our dB thing, and it turns out to be 6 dB. So I already knew that matching resistors in my feedback loop are going to give me 6 dB of gain, and essentially what I was doing is this and this in my header from just experience. So let's build that in there. Let's build this guy. And this will be kind of fun. So diving over to multi-sim, let's go take it out of play mode here and schematic, and go drag down here. We need to see this a little bit more. We need to put an op-amp in here, so another little guy. So another 3-terminal op-amp, stick it in, and of course we need to flip-flop it with the flip-floppy tool here, whatever you want to call that. Introvert, retrograde, reverse is probably the proper term. I'll stick that right there. And of course, let's wire up the non-inverting input. And on the output, we are going to need a little lead over here in a moment. And let's make another one here. And this one's a little bit more complicated. We're going to need to put a resistor value here. And let's do that. So R is for resistor. And that's a 10K resistor. So let's type in 10K. And let's also drop in our ground. We know we're going to need a ground. That looks about right. And we're going to need another 10K resistor. And I'm going to flip it on its side. Make that 10K. So they are now matching. And kind of put that about right there. And let's connect them all up. J to J. This guy's going to go right to there. And this guy needs to go right there. So now we got a voltage divider. It's just going to reduce the level by half. Because it's pretty simple math here. Half's going to drop there and half's going to drop there to ground. That's how it works. So by reducing the level by half coming into the negative terminal, it's going to create it's going to tell the amplifier to double its output level. Shall we confirm that? Absolutely, we should. Let's get a voltage here, and we'll drop this on the very output here. And let's do it before we even go to before we bring the scope up. We should press play and stop, and you should see a number. It's about twice, and you do. Minus 200 millivolts at this moment, minus 400 volts at this moment. Of course, it's going to be different all the time because it's AC. So we got another negative terminal. Let's negative value here. Let's see. Seem to be catching negative values each time. But it doesn't. Oh, here's a positive value, and you can see that it's double. So I wonder what that looks like on the scope. Let's check that out. Interactive. Let's bring up split, and we'll press play here. I think it's already simulating it. And now what you're seeing in pink here is the output probe here, probe 4. And you can see it's not quite perfect, but it's definitely a lot better off than it was before. And so that's our makeup gain. And let's just confirm. I'm pretty sure that what we have to do next is take a screenshot of this. And yep, and call that screenshot 6finalscope.yourname. And save that screenshot. You have one more screenshot to do. Let's do the same thing, but do this with a sweep. So we'll change interactive to AC sweep. Press play. Get a lot of stuff on the screen. Let's hide the traces we don't care, including the phase traces on probe 4. So we're really comparing probe 3 to probe 4 here, and now you can see that it has some makeup gain in there. In fact, we do need to reset all the values because the program doesn't seem to be smart enough to remember this. So go back to dB, and now it's more what we want. And you can see that part of this band is actually above 0. I have some positive gain in that area, but it's I don't know. It's a little bit more unity gain than it was before, where everything was below 0. So this, of course, is going to be your last screenshot. You're going to take a full screenshot like you've been all along of the whole page so I can see your assignment name and all that. You definitely want to have done that for all your screenshots going forward so I can really see your name up there and the whole thing. And that last screenshot, of course, is going to be named Final Sweep 7, Final Sweep, your name, last name. I really appreciate you having your numbers on there. I can really quickly sequence through there, make sure, watch you build in stop animation the circuit in 7 mouse clicks. So the last thing you're going to do for submission is kind of pile this all up together. First thing is I want, if you can, in the Canvas assignment comments for this, if you could paste in the name of your circuit. It's pretty easy here. You can just double click on it and copy, and then you can paste that in there. That way I can search for that on the web, whatever name you've used for it. I can search for it in MultiSim and look at it online. But essentially you're going to bundle in a folder these 7 screenshots that you've done, 1 through 7, all of them. You're going to stick them in a folder. You're going to zip them up, that folder. You do know how to zip a folder, right? Pretty easy on a Mac. Go to Finder, File, Compress. It's real simple. Stick all these screenshots into a folder. Let's say this folder right here, downloads. You can actually right-click on a Mac and do compress. That makes a zip folder. It's an easy thing to do. And then you're going to upload that, drop that in the Canvas assignment, and you're all good. If you're curious about how I'm going to grade, there's a rubric here. Basically, did you follow instructions, and are all the screenshots there, and all the screenshots that show the correct circuit. And hit me up if you have any questions. I've done my best to try to keep the video and instructions accurate. I'm sure I missed something along the way. It always happens. But I'm pretty excited to have this assignment because I think it's pretty cool. It's pretty darn cool. All right, guys. Have a great morning, evening, or whatever it is you're doing this assignment at. Bye-bye.